So in this video, we're looking at 7th grade module 1, lesson 11, 12, and 13, where we'll be solving problems based off of proportionality and finding the constant of proportionality. So in lesson 11, our first problem, which there are 7 of them. First one, it wants us to use a double number line to solve this problem about Sean's road trip. So it says Sean and his family are on a road trip. They drive at an average speed of 70 miles per hour. On the highway, use a double number line to show how many miles Sean's family drives during times ranging from 0 to 10 hours. So that gives us some information that we can start putting down in this number line. We're going to look at the hours first. We're going to go ahead and label those, starting with 0 and working our way all the way up to 10. And they actually give us our constant of proportionality, or our unit rate in this problem. They let us know right here that they went 70 miles per hour. So if they went 0 hours, they went 0 miles. If they drove for 1 hour, it was 70 miles. For 2 hours, 140, and so on and so forth. And we'll come back to this double number line in a second when we solve our problems. So moving on to the problem, it says for part A through C, use the double number line to determine the distance for Sean's family's drives. So the first thing we're looking for is how far did Sean's family go in 8.5 hours. So we're going to come to our number line and use that number line to figure out where is 8.5 hours. Well, 8.5 hours is sitting right here, dead between 8 and 9 hours. So we're looking to figure out how much this is. So to figure out how much that is, we need to figure out what this distance is. So each of these tick marks, the distance in between them is 70 miles. So we're trying to figure out what the halfway point of that 70 divided by 2, we're trying to get in that half area, would be another 35 miles. So if we went 560 plus another 35 right here, we just add those two numbers together and get our answer of 595 miles. So in 8.5 hours, they go 595 miles. Now they want to figure out for 30 minutes. So 30 minutes is a half an hour. So half an hour is here at 0.5. So we're looking for another half. So we've got all of this tick mark is equal to 70. Half of 70 is, just like we said a little while ago, 35. So in a half an hour, they go 35 miles. Then it says Sean's family drives for T hours. So they don't actually give us a number, but if you looked at how we figured out all of those numbers at the top, the number of miles, all we did was take the number of hours, in this case a T, and we multiplied it by 70. So 70 times however many hours they drove is going to give us the answer for the miles. Then for letter D, number 3, it says write an equation relating the amount of time, T in hours, to the total distance they drive, D. Well, now we have to look at it and say, okay, well, if I'm writing an equation, that would be y is equal to kx. And we should always start that off when we're looking to do an equation. And then we're going to go ahead and replace the y with one of these letters, but we got to figure out which one. So the easiest way to do that is to figure out the x first. So we're going to figure out what this x is going to be. The x is always whatever you want to become a 1. So we're looking for what's going to be a 1. Do you want to find out how many miles they drive per hour? Or do you want to figure out how many hours it takes them to go 1 mile? Now, when we talk about time, we said we always want our time to become a 1. So this is going to be our x. So instead of an x, I'm going to go ahead and put my t, which means that the distance is going to be my y. So I'm going to go ahead and put a d instead of the y. And then we just got to put the k, and we know our constant proportionality, our unit rate is 70 miles per hour. So there is our amount. Then number 4 says identify the constant proportionality, explain what it represents in this situation. The constant is 70, and it means they go 70 miles in 1 hour. So the next problem that we're going to do together is going to be number 5, and then I'm going to let you take care of number 6 and 7 on your own. So for number 5, it says a hose completely fills a 15-gallon container with water in 1.5 minutes. What is the unit rate? What does it mean in this situation? So when we hear unit rate, we should also think constant proportionality. When you hear constant proportionality, you should be using the formula K is equal to Y over X. This is going to ensure that you're doing the right problem. So again, we have to figure out what is going to be our X. What do we want to become 1? Well, again, we have a measurement of time here. So time is going to be our X. How many gallons per minute? So gallons is going to be our Y. So we're going to do 15 over the 1.5, which means the problem that we need to be doing is 15 divided by 1.5. So 15 divided by 1.5. We have a decimal on the outside, so we're going to move that once, which means we're going to move the one on the inside once. This problem is going to become 150 divided by 15, which you can see goes 10 times. So our constant proportionality is 10, which means we can pump, or the hose's rate is 10 gallons per minute, or 10 gallons for every minute, however you want to word that. And then it says to write an equation. So again, just like the last problem, you want to write an equation. Y is equal to kx. We just said a little while ago, we also have to define our variables. So we know that the gallons is our y, our minutes is our x. So if we want to define our variables, we can say let G represent gallons and let M represent the minutes. So instead of a Y, we're going to put a G for our gallons. We found our constant proportionality just a second ago is a 10, and then our minutes is going to be our X, so an M, and that is going to be our equation. We go to the next part of the problem, part C. It says, how long does it take for that same hose to fill a 2,000-gallon pool? So this is where we actually use our equation, and which you will have to do in your test. So we take that equation, we rewrite the equation. Now we need to look and see what number do they give us. Well, they give us 2,000 in gallons. So we're going to replace the G in our equation with 2,000. Leave everything else the same. To get M by itself, we need to divide this side by 10, which means we divide this side by 10. So on this side, 10 divided by 10 is 1, so it's going to leave us with 1M. On the other side, we do 2,000 divided by 10, which goes into 20 twice. And then we just got 2 zeros. So it's going to take 200 minutes to fill that 2,000-gallon swimming pool. Now you go ahead and take a look at problem 6 and 7. Pause the video. You try this on your own, and then come back and I'll have the problem all worked out for you. All right, so go ahead and pause that video if you haven't yet. We'll give it about 5 seconds, and then we'll switch over to our answers for number 6. And here are those answers for number 6. So it says you count 20 heartbeats in 15 seconds. Again, we're trying to get that time to become our 1, so that is going to be our X. And they want us to find the unit rate of the constant of proportionality. So it's going to be Y over X, which is going to be 20 divided by 15, which we did that problem right over here. We went one whole time. We had a remainder of 5, and our divisor was 15. So I got 1 5/15, which I then simplified to 1 1/3. In this case, if you did it as a decimal, you see it would be repeating. So that is not a very accurate number. To be more accurate, just go ahead and leave it as a mixed number, which is what I did. So then part B, it says to write your equation. So again, every time you see equation, you should be starting with this to make sure you put everything in the right place. In my case, I let H represent the heartbeats and S represent the seconds. You could use whatever variables you want. So instead of a Y, I put an H. Our constant proportionality for K is 1 1/3. And then for the X, I put S for seconds. Down here at the bottom, it says at this rate, how many times does your heart beat in a minute? Well, a minute is equal to 60 seconds, and we're talking about S for seconds. So I rewrote the equation here, plugged in a 60 seconds for the S, which you can see right here. And then I did 1/3 times 60, which gave me the answer 80. So now if you haven't done so, you can finish up number 7 and then come back and we'll have that answer. All right, and if you're ready to see that next number 7, here we go right now. So in this problem, it talks about $1.80 gets you 12 pencils, and this time it doesn't talk about time. So you have to see what is it that you want to figure out. Do you want to figure out how many pieces of a pencil do you get for a cent or a penny, or how much money it costs for one pencil? And that obviously would be how much it costs for one pencil, which is why my pencil is my X, my money is going to be my Y. So to find the constant proportionality, K is equal to Y over X. It's going to be 180 divided by 12, which that division problem is here. And it gets me 15 cents per pencil. To write that equation, Y is equal to KX. I let C represent my cost and P represent my pencils, and came up with this equation right here. And then I used that equation to solve the problem, how many pencils can I buy with $12? So instead of a C, I put 12. Had to divide both sides by 0.15, which ends up being the problem 1200 divided by 15, and I get an answer of 80 pencils. All right, and this is lesson 12, where we're going to be filling in some tables. Lesson 12 and lesson 13 are basically the same exact thing. So we really could we'll just do lesson 12, because it's honestly the same thing, except lesson 13 just has more columns. It adds another column or two. So number 1 says Maya creates a comic strip about a superhero. The superhero is drawn in different sizes and poses in different frames of the comic strip. However, Maya wants the ratio of the length of the head from the chin to the top of his hair to the length of the body from the toes to the bottom of the head to be constant in every frame. So what that all means is she's made a comic strip. Sometimes the hero is going to look like it's far away, so it needs to be small. Sometimes it's going to look like it's close up, so it's going to be big. And she doesn't want it to look funny where the head is bigger than the body. So she wants to figure out the different ratios, or to keep it proportional, so that it looks like the head and the body belong to each other no matter how close or how far it is. So we're going to be completing this table using the information that they give us. So if we look, and we're not gonna worry about this last column just yet. We're not gonna worry about that right now. We're just gonna do this table as if it's 2 columns, just like we always do. So looking at this table, there's only one row that gives us information that we can use. We have this right here, and like every table, X always comes before Y, because that's in the alphabet. X, Y, Z. So there's our X, there's our Y. We need to figure out what the constant proportionality is here. So that's going to be K is equal to Y over X. If we look at the table, 18 is our Y. And 2 1/4 is our X. So that math problem is 18 divided by 2 1/4. We're going to make those become fractions. So 18 over 1. Divided by 4 times 2 is 8, plus 1 is 9, so 9/4. Now we can do keep, change, flip. Just like so. We've got 18 times 4. And that gives us 72. over 9, and 72 divided by 9 gives us an 8. So that constant proportionality is an 8, which means I'm multiplying everything on the left by 8 to get the number on the right. So to get our first number, we're going to be doing 3/4 times 8. 3 times 4 is 24. 4 times 1 is 4. 24 divided by 4 is 6. So that missing number here is a 6. For the next one, you can see that there is no number. So if there is no number to multiply times 8, we're going to do the opposite, go the opposite direction. And that's going to be 6 2/5. And if we go in the opposite direction, we need to do the opposite sign. So instead of multiplying, we're dividing by 8. So let's change those numbers. That's going to be 5 times 6 is 30, plus 2 is 32/5, divided by 8 over 1. Keep change flip. It's going to give us 32 over 40. If we divide both of those by 8, we get 4/5. So our missing number here is 4/5. And our last one, you'll see we have no numbers here. The only thing that we do have is in this all the way right hand column is equal to 8. But it's, the numbers are actually pretty easy. If you just look at our constant of proportionality, it's an 8. So we said constant proportionality was equal to k is equal to y over x. So if we wrote that as a fraction, that would be 8 over 1. Our y is an 8 and our x is a 1. So that our x in the table is a 1 and our y in the table is an 8. And 1 plus 8 equals to this 9. So now to get the last table, the last column, we just need to add our numbers up. So we got 3/4 plus a 6. That's going to be 6 3/4. We got 4/5 plus 6 2/5. So 6 plus no whole number is going to stay 6. 4/5 plus 2/5 is 6/5. But we can take a whole out of that. So take that whole out of this. That's going to make it a 7. And then if we take 5/5 out of 6/5, that leaves us with 1/5. And then the last one, we got 2 plus 18, which is 20. And then with that 1/4, it'd be 20 1/4. So then we have, what is the value of the ratio of the head? So we're doing the head to the body. So head to body. And let me clean this up a little bit. I'm going to be using the row that has all of the whole numbers. So I'm going to concentrate on this row right here to do this because it's going to be the easiest. So if I wanted to write a ratio, a value of a ratio, first thing I'm going to do is write a ratio. So the head to the body, you can see that that ratio would be 1 to 8. To write the value of a ratio, that would be 1 over 8, 1/8. It's the value of a ratio, which is another way to write a ratio, but as a fraction. So then our next one, part C, says what is the value of the ratio of the body to the total length? So if we're looking at the body to the total length, that would be 8 to 9. And that value would be 8 over 9. The next one says the head to the total length. Head to total length would be 1 to 9 or 1 over 9. And then it says using the values of the ratios you identified, write equations for at least 3 different proportional relationships. So we're going to use those values that we just wrote. The first one that we wrote was 1 over 8. And that is the head to the body. So we can use y is equal to kx. If you go back and look at the table, the body was the x. The body, was in the y space. So if you go back to this table, the body is y. Oh, wrong way. So the body is y. I'm going to put a b for body. The constant proportionality is that value that we found, so 1/8. And then the x is going to be the head. I think I used the right variables. Let me check and see. Yep, b and h. Okay. So that is our first equation, which means that the head is 1/8 the size of the body. Now, if we use the next one that we did, we had 8/9. So 8 was for the body, and the 9 was for the total. So if you go back and look at that table, now you're just looking at these two columns. So that means that now this one comes first. So the body is going to be the x. The total is going to be the y. So we're going to go ahead and do y is equal to kx. The total is the y. And you can also so the total is going to be the y. The constant is 8/9, and then we have the I said that wrong in the table. We know we don't use a table for that. My apologies. We have to use our constant proportionality. So it is y is equal to kx, and just like we have it here, this is the y, this is the x. I'm sorry. So the body is our y, and that is equal to 8/9 times the total, because the body is 8/9 of the total. So that is our second equation that would go under part C. I just wrote it in a different spot. And then in the last one, we got 1/9. This is going to be the head, which again technically is our y. This is our total, and since it's on the bottom, that is our x. So y is equal to kx. The y is going to be the head. The constant is 1/9, and then as multiplied times the total. And that's all we have. Again, lesson 13 is the same exact thing. The only thing we need to worry about is being able to fill in one of these tables. So it's just like any other table. You just concentrate on the first two columns and then add the third column. And that is all we need to do. If you have any questions, let me know.